Okay, so here, and I laid out specifically what I want done. So since Danny's not here, let's just do one group of 5, okay?
Yay.
But you're going to hand in one paper per group, okay? But you make sure everybody knows what's going on. So this is a situation where I'm just going to give you the task, you figure it out. So, in terms of how you're going to calculate the moment of inertia, it's a tennis ball. Treat it as a hollow sphere, okay? There's a specific moment of inertia for a hollow sphere. So, you're going to set this board somewhere between 10 and 20 degrees. I care not, somewhere between 10 and 20. You're going to hold it up to a specific height, okay? I care not. Obviously, don't do this, okay? You can go all the way to the top, whatever. So here's what you're going to do. You're going to measure whatever information that you need to measure. And then, and again, here's the idea, is that someone should be able to take your information and replicate your results. Okay? So what are you going to measure? Where are you going to measure from? So let me give you a hint. So one of the things you need to decide is that when you're measuring height, are you going to measure from the center of the mass of the ball? Or are you going to measure from the bottom of the ball? Because it's got to get down here to the bottom. Where are you going to measure from? Okay? Just be consistent, all right? I don't care where you measure from, but you don't want, if you're going to measure from the center mass of the ball, then you need to measure to the center mass of the ball. But then if that's the case, then when you get down to the bottom, center mass of the ball isn't at the table, okay? Center mass is above the table. So again, I don't care where you measure, just be consistent. How are you going to determine the radius of the tennis ball? You're going to wrap a string around it, you're just going to kind of eyeball it. What are you going to do? How are you going to get the radius of that tennis ball? So, here's the main idea. You're going to have kind of 2 different sets of things. You're going to have a theoretical translational kinetic energy at the bottom, a theoretical rotational kinetic energy at the bottom, then an experimental acceleration as it rolls down the hill, then your actual final translational kinetic energy, and then your experimental value. Relevant data, you need to answer one question. Assuming no frictional loss, how far would a spring have to be compressed to launch your tennis ball back up the ramp to the same height if K equals 75 newtons per meter? So on that question, visualize this. You're going to compress a spring so that that spring shoots that tennis ball up here. Now, to make that question simple, you're just assuming that it's just going to slide up. You don't have to take rotational kinetic energy into that aspect because that gets real ugly and real weird real fast. So I said, okay, hey, let's just make it a little bit simpler. So again, there's a whole bunch that you need to do. I beg of you, do not let, and I doubt this, I know this isn't going to happen, but I just want to emphasize this. Because this is kind of like your summation lab final over this whole thing, okay? Make sure everybody in the group knows what's going on, even though you're just handing in one paper. It needs to be done nicely, so that means some people are not allowed to write. Because I want to be impressed, okay? So, literally, this is what you need to do. When you hand this in, you're going to say, here's this, here's this, here's this, here's this, here's this, okay? The worst thing that can happen is numbers magically appear, okay? That's going to be bad.
I love magic numbers.
All right, so here's the story. You have the rest of the time today to work on this. Collecting the data is relatively simple. The math and the theoretical calculations take a while. So this is going to be due on the day of the test on Wednesday, okay? So you don't have any homework tonight other than this. The test is on Wednesday. Here's my concern is that we've had a very long break and you all have offloaded a lot of stuff.
Yeah.
So I would highly suggest that you go back, revisit energy, conservation of energy, how you work those problems.
How do springs work?
Oh yeah, the spring constant, which is Newton's.
That's a thing that
Newton's
exists.
per-
That is very much a thing that exists. So, yeah. So we'll review tomorrow,
This is not going to go good.
test on
I have a
Wednesday.
lot of physics things that
Now,
I need to review.
Even on a I'm just telling you now, this test average on energy tends to be a little sketchy.
Is it lower than planetary motion?
Historically, yes. Not
Oh.
every year, but on
I
average,
just got my
yes.
grade back up.
No.
But here's the weird thing about that test. It either goes really, really well or it tends to be an absolute train wreck. Like either you get it or you don't. And there is not a lot in between. So just keep that in
Let's
mind.
hope I get it.
Okay, I'm
I hope
done.
I
You're on
got
your
it, 'cause
own.
I
I know
got
what I'm going to get.
I did it.
Okay, I need to see your 5.
It's okay, guys. One at a time.
Will, did you shut down that camera?
Oh, no.
That's fine.